Hello, students. Very good afternoon to all of you. This is Mona Lisa Paul. I'm your teacher, and today I'm going to teach you about the Lotka Volterra model. It is also known as the predatory prey model, a very important model of the ecology. Now, we must have heard about different kinds of competition. So, predation is one of the kind of its competition, where a predator actively kills a prey, a life killing takes place, and then it eats that prey. You must have seen it in your, National Geographic or in most of the Discovery channels and all, that a lion is chasing, and suddenly the lion is, coming and fighting, and all those things are happening. So those are predation basically. Now, there were two mathematicians in 1925. They developed this model. These mathematical models help in predicting the trends or the variations in the future. And mind you, this is very, very difficult to predict something in nature on its or in ecology. You know why? Because the ecology or the environment, it is very dynamic. So we need to have a data for a very long time, that how, what was the population and everything. That's the thing. Basically, this Lotka Volterra model or predator prey model, it is based on the assumptions. I'll talk about that later, but let us see what is this predator prey model. I think you're able to see the screen. Okay, fine. You will show me a thumbs up. Yeah, fine. Now, coming to the very first equation of Lotka Volterra equations, our first equation, it is dx by dt equals to alpha x minus beta xy. I'll explain you each and every term. Now, if you see this dx upon dt, you must have done your differentiation in class 11th or class 12th, part of calculus, integration, differentiation. So it is also part of, this is dx upon dt is always, it is the instantaneous growth rate. X stands for the population density of the prey. Okay, rabbit. Suppose I take fox and rabbit. It is the population density of the rabbit, X. Okay. Alpha. Alpha is the maximum prey per capita growth rate. That what is the maximum growth can take place. So dx upon dt, anything dt, dp upon dt, anything like that, it is the instantaneous growth rate. What is the growth rate at a particular instant? Now I'm using the term growth rate. Have you wondered what is growth rate? It is basically, in layman's term, it is the birth rate minus the death rate. Now, what is birth rate? It is the number of individuals born per 1,000 individuals. And death rate, number of individuals dying per 1,000 individuals. So, what is left between death and birth? Or birth or death, it is the growth. So birth rate minus death rate, it is always the growth rate. Now it can be positive, it can be negative. Suppose growth rate is more than the birth rate, then definitely the answer will come in negative. That means the growth is going, it is decelerating, it is not increasing or accelerating. And if it is positive, that means it is increasing. Now, X is already told about the population density of the prey, and alpha is the factor which is the maximum prey per capita growth rate. Fine. Now, if you just see only up to this point of the equation, that dx upon dt equals to alpha x. Alpha x means the exponential growth of the prey. और ये कब हो सकता है? When is it possible? When there is no predator at all, and only rabbits are flourishing, or only grasses are flourishing in the absence of their respective predators. Like if there is no fox, all rabbits will keep on, they will keep on growing. So it is exponential growth. Like I'll talk, all those things are related to your S-curved shape, S-shaped curves and your J-shaped curves, and all those things I'll, explain you later. Today, let's understand the basic Lotka-Volterra equations. But there is a factor, Y. Now, what is Y? Y is the population density of the predator. Let it be fox, let it be lion, let it be alligator, let it be deer in case of grass and deer relation. Let it be. Okay. It is the predator, how much predation is taking place. And beta, it is the effect of the presence of predators on the prey death rate. That means whenever there is an interaction or competition between the predator and prey, there has to be an interaction. This XY is basically showing the interaction, how much interaction is taking place. So, in a very short, in a very sweet and in a very simple way, the equation 1 explains that the rate of growth of population of prey or prey's population or density of population is directly proportional to the exponential growth of the prey minus the number of preys that are being preyed upon or that are being eaten upon or that are being destroyed or that are being taken up by the predator. Is it okay? Show me a thumbs up. Fine. This is a very simple equation. Now coming to the second equation. If there is a predator, there has to be a prey. Already we have talked about. So it is dy by dt. Now dy by dt will be the instantaneous growth rate. Okay, instantaneous growth rate is equals to minus gamma y plus delta xy. Xy remains the same. It is the interaction between the predator and prey. There has to be some interaction. So it is the predator prey, this equation is there. Okay, that interaction is there. Now, gamma stands for the predator's maximum capita death rate. Now, predator, due to emigration or due to natural, any circumstances like any virus attack or maybe natural death or maybe due to emigration, number of predators, they are going back. So this gamma is a factor and that's why it is minus. Why minus? Because when death occurs, it is decreasing the density of the population. When it is decreasing, how it is decreasing? Because it is decreasing the number of people from the population size. So definitely growth rate is dependent on it. Like it was alpha x because it was the birth rate, how much they were growing. Here it is the death rate, has to be, it is minus. And this is your delta. Delta is the effect of the presence of prey on the predator's growth rate. So in short, the growth rate of the predator is directly proportional to the proportional to the interaction between the predator and prey minus the death rate of the predator. So if that means if there is less number of prey, obviously there will be, if there is less number of predator, definitely the height or the what you call the population of the prey will increase. Like if there are no foxes, definitely rabbits population will increase. It is simple as that. But there are many assumptions to it. What are the assumptions? Assumption is that the prey, that is X, it gets ample food option. The rabbit not only eats what? Grass, but it will eat any foliage, it will eat any herbs, it will eat any shrub, it will eat anything, so that its population can grow naturally. Okay. Similarly, the predator or Y, they should have ample appetite. Okay, let whatever number of suppose a lion is hunting a hare, and it has immense appetite, then it is eating randomly and very successively all the rabbits. So that kind of thing is very much required. Then third number is that the conditions, external conditions and all, they are very stable. There is no earthquake, there is no tsunami, there is no natural disaster. That means this process or this chain or this mathematical model is going very smoothly. Fourth, in whatever amount of food is eaten by the predator, it is immediately taking, it is immediately being, consumed or converted into the number of offsprings produced by the predators. Okay, that is going towards the birth rate. Fine, these are few assumptions are there. Now, if I in the next slide, if you see the basic graph of predator-prey model, then if you see on x-axis, this is time has been plotted, and on y-axis, the population of both prey, that is in light green, and predators, it's in gray color. Now, if you see, when the population of prey is high, that means the population of predators has to be low. Definitely, if there are less number of lions or less number of foxes, then only the population of your rabbit can thrive well. They can grow well. So this is very, very important. You have to understand this. Similarly, but initially, if you see, like but there a point will come when both of them may be zero. Why zero? Why? Because if there is no prey, initially, if predator eats all that sprays, suppose all the rabbits are finished, they are all vanished, a time will come there will not be any prey left to the predator until and unless, okay, until and unless it moves to switching. That is a different concept of ecology, or the comparative ecology, or the interactive ecology, where a prey immediately switches to the next, where the predator immediately switches to the next prey. If the rabbits are finished, no problem, let's shift to zebras. If zebras are finished, let's shift to any other herbivore which can be easily chased upon, which can be easily preyed upon. So if a time will come when, if the predator is prey becomes zero, that is all rabbits are finished, similarly all prey will become finished, because if there are no rabbits left, ultimately the predator will die out of hunger, or its population will decrease due to hunger, disease, and other things. So it has to immediately go to that switching mode. They have to change their predation preference in that case. And related to this, a concept called red queen effect has been developed. Again, it is a concept of ecology. Red queen developed, it has come from the Alice in Wonderland theory. What is that? Like the queen, there was a Alice in Wonderland, there's a big famous animation, there's a famous story, in that case, Alice was told by a red queen, there was a character, these were the two characters, that you have to, darling, you have to keep on growing yourself, you have to keep on moving yourself so that nobody can harm you, you have to evolve yourself. In nature, both predator and prey, they show this red queen effect, where both of them keep on evolving over the time period, keep on evolving their skill sets, keep on evolving their genetic makeup, keep on evolving their different kind of predation sets, so that they can, who can be at the top. Again, Darwin gave the theory of struggle for the existence and the survival of the fittest. Whosoever is the fit will continue, and the weak one will be wiped out. Hope your doubt has been cleared. Thank you for joining me, and please keep looking on for other videos as well. Thank you so much.